Okay, this is my third time recording this video, so hopefully this goes well. Now let's say we have the exponential equation 3 to the x plus 2 is equal to 9 to the 2x minus 3. Okay, how can we solve that exponential equation? What do you think we need to do? Well, whenever you have an exponential on the left side and an exponential on the right side, it's best to convert them into a common base. And we can clearly see that 3 and 9 has a common base of 3. So this can be 3 to the first raised to the x plus 2, or simply 3 to the x plus 2. Now 9, we can rewrite that as a common base of 3, but raised to the second power, 3 squared. So we're going to write that as 3 squared, and again, it's raised to 2x minus 3. Don't forget that part. Okay, now we need to multiply, because whenever you have an exponent raised to another exponent, remember that rule, you gotta multiply. So this is gonna be 3 to the, let's distribute 2 to 2x minus 3. This will be 2, this will be 4x minus 6. Now that the bases are the same, notice that we have a base 3 in here and the base 3 in here. The bases are the same. Whenever you see the bases are the same, that means the exponents are equal to each other. So we can say that x plus 2 is equal to 4x minus 6. Now we have a basic equation that hopefully you know how to solve. And let's also not forget about adding 6 to get rid of that negative 6. So this will cancel and this will cancel. So we're going to get a equals 3x. So if we divide by 3, we're going to get that x is equal to 8 divided by 3. And so that is the value of x. Basically, you had to convert it into a common base, then you have to multiply the exponents. When you have the bases that are the same, the exponents are equal to each other, and then you can just solve for x from there on. Now let's try another example similar to that, so you kind of get hang to it. It's like you get the hang of it. So let's try another example like that. Let's say we have, this erasing quite takes me a lot of time, I'm not gonna lie. Okay, so let's say that we have 8 to the 4x minus 12, 8 to the 4x minus 12, and that's equal to 16 to the 5x minus 3. Okay, so what do you think we need to do? Well, we need to change those bases into a common base. That way we can solve for x. And we can clearly see that 8 and 16 has a common base of 2. So we can rewrite 8 as 2 cubed and 4x minus 12 again. And we can rewrite 16 as a common base of 2, but 2 to the 4th power and 5x minus 3. Okay, now we need to multiply, because when I have an exponent raised to another exponent, you need to multiply. So 2 to the 3 times 4x minus 12, that's going to be 12x minus 36 is equal to 4 times x minus 3 is 20x minus 12. Yeah. Okay, now that the bases are the same, that means the exponents are equal to each other. So 12x minus 36 is equal to 20x minus 12. We can subtract by 12x, as well as getting rid of that negative 12 by adding 12. So this will cancel. So negative 36 plus 12 is negative 24 is equal to 8x. Now if we divide by 8, we're going to get the value of x, that x is equal to negative 3. 24 divided by 8 is negative 3. Because when you have a negative divided by positive, you're going to get a negative solution. So that's the answer for that one. So as you can see, x equals negative, and you can plug it in. 4 times negative 3, negative 12, 8 to the negative 24 is equal to 16. It's going to work if you do the arithmetic. It will work. You just got to check it. Now, let's try this example. Let's say we have, let me write it here. Let's say we have 27, let me write here, 27 to the 3x minus 2. And let's say that's equal to 81 to the 2x plus 7. So we need to convert it into a common base. 21 and 27 and 81 has a common base of 3. So we can rewrite 27 as 3 cubed. And the reason why you want to get a common base is that way the exponents are equal to each other and it's very easy to solve for x. You want to make the equation so simple in such a way you can solve for x very, very easily. So this is going to be 3x minus 2. And 81 is basically 3 to the 4th power and 2x plus 7. Okay, now let's multiply. So 3 to the 3 times 3x minus 2 is 9x minus 6. This is 9 minus 9x minus 6. 3 to the 4th is going to be 3 times, okay, this will be 8x plus 28. Now that the bases are the same, we have 3 here. Exponents are equal to each other, so 9x minus 6 is equal to 8x plus 28. I know my 8 is terrible. Now I'll subtract 8x from both sides, and we're gonna add 6. So this will cancel. 9x minus 8x is simply x, and this will also cancel. And 28 plus 6 is 34. So that is the value of x in that equation. So as you can see, that is the value of x. So now let's try another example that is a bit harder. Okay, let's say we have the exponential equation. This is going to be a little bit harder because you're going to have to use a special function called logarithms. So we're going to be having 3 to the x is equal to, let's say, 8. So how can we solve for x in this equation? Notice that we can't really take a common base. 3 and 8 does have a common base. 1 won't, yeah, 1 won't work, 2 won't work, 2 first, it's not going to work. So we can't convert this 3 and 8 into a common base. So what do you think we need to do? Whenever you have a situation where you can't take out the common base, it's good to use logs. It's good to take the log of both sides. So if we take the log of both sides, we're going to have the log 30 to the x is equal to log 8. Now, once you have that, a property of logarithms lets us to move the exponent to in front of the log. It lets us to move the exponent in front of the log function. So we can rewrite this as, it's a property of logs. We can move the exponent to the front. So we can say it's x logarithm 3 is equal to log 8. Now, if you want to get this x variable by itself, we want to get rid of this log 3. You want to get that x variable by itself. So in order to get rid of that log 3, what we're going to do is divide by log 3. So if we divide by log 3, we're going to get that. We're going to get that x is equal to log 8 divided by log 3. Now, obviously, if they ask you in the test for the decimal value, you can just go ahead, plug that into your calculator, and you should get the answer, if you want the decimal value. But that is it for that example. Remember, whenever you can't convert into a common base, you must use logarithms. If it's an e-base, you have to use natural logarithms, though. Now, let's try a similar example, except we need to use a different one. So let's say we have e to the x is equal to 7. So, obviously, we can't convert into a common base. E is 2.718, so we're not going to be able to convert this into a common base. Now, whenever you have e, you don't want to take the log of both sides. Instead, you want to take the natural log. If it's just a number 3, 5, 9, or anything like pi, I guess, if it's just some constant, some generic constant, e is also constant, but the other constants, that's okay. Then take the log of both sides, but then take the normal log of both sides. But whenever you have e, you want to take the natural log. So this is going to be ln e to the x is equal to ln 7. You want to take the natural log of both sides if you have an e base. Now, a property of natural logarithms lets us to move the exponent to the front. So we can write this as x ln e is equal to ln 7. Now, ln e is 1, so it's basically saying that x times 1 equals ln 7, or so x times 1 equals ln 7, or simply x equals ln 7. So that is the value of x. As you can see, that one was a simple equation, but yeah, that is the answer for that one. Now, let's try another example where we need to do a couple more steps in order for us to use the properties of the logarithms. So let's say that we have 5 plus 4 to the x minus 2 is equal to 23. Okay, so how can you solve for x in this one? Well, first, what I highly recommend doing is getting rid of this 5. That way we have the exponential by itself, and then we can use natural logs or convert into a common base and stuff like that. So first of all, let's just get rid of the 5. So let's begin by subtracting both sides by 5. So we're gonna cancel this. So 4 to the x minus 2 is equal to 20 minus 5, so 18. Now, we don't need to use any logarithms. I mean, you could, it's just gonna be a waste of time. We can convert, no, we can't actually, sorry. We can't convert these into common base. We have to use logarithms, I'm sorry. So yeah, we cannot come, because 2 to the 4th is 16. For some reason, I thought that was a 16, but that's an 18. So we can't convert this into a common base. So we're not going to use natural logarithms because that's for base e. We're going to use the logarithm. So if you take the log of both sides, log 4 to the x minus 2 is equal to log 18. Let me just keep x minus 2 in parentheses, x minus 2. Okay, now property of logarithms lets us to move the exponent to the front. So it's going to be x minus 2 log 4 is equal to log 18. Now you should not distribute log 4 to x minus 2. That's not really going to be that efficient. You shouldn't do that. Instead, what you should do is divide by log 4. So what we're going to do is divide by log 4. I'm running out of space, but let's divide by log 4. Now, we're going to get that x minus 2 is equal to log 18. Well, we don't need the parentheses anymore since that's not really going to be grouped. Log 18 divided by log 4. Now at this point we have a basic equation, so we can just add 2 to both sides. So we're going to get that x equals 2 plus log 18 divided by log 4. No, it's not all over log 4. It's log 18 plus log 18 divided by log 4. And that is the answer for x. So that's the solution for x in that example. Now let's try another practice problem for you to work on. So we have 3 plus, let's say 2e to the 3 minus x, and it's equal to 7. Okay, so what do you think we need to do to solve for x? So what this is a minus, not a plus, by the way. This is a minus sign, okay? This is 2e to the raised to 3 minus x. Now, first of all, obviously, I think you know that we're going to get rid of this 3. That way we have the exponential by itself. So let's begin by subtracting both sides by 3. So 2e to the 3 minus x is equal to 7 minus 34. Now, since the 2 is being multiplied to e, to separate the 2 from the exponential, we're going to divide both sides by 2. E to the 3 minus x is equal to 4 divided by 2. Now, we need to use natural logarithms, not logarithms, because we have an e base, right? So we need to use natural. So if you take the natural of both sides, you're going to have ln. That looks like an in. So we're going to be having, we're going to be having ln e to the 3 minus x is equal to ln 2, because we took ln on both sides, natural log of both sides. Now we can move this to the front, so this is going to be 3 minus x ln e equals ln 2. Oh my god, I keep writing in. ln 2. Now ln e is 1, so that will just disappear. That's just 1. So this is just going to be 3 minus x. Don't need the parentheses anymore because it's not really going to be grouped. 3 minus x is equal to ln 2. Now what I'm going to do is move the negative x to the other side, and the reason is it's going to be more easier because it's easier to deal with positive x's than negative x's. It's easier to deal with positive numbers. So I'm going to move this to the other side. So it's going to be 3 equals ln2 plus x because I moved it. Now to solve for x, I'm going to subtract by ln2, which I can't really write here, but 3 minus ln2 is equal to x, and the sign will change. And so that is the answer for x. That is the solution. So that is the answer. Now let's try another example. This example might seem a little bit confusing at first. It might seem confusing at first, but let's say we have 3 to the x squared plus 4x is equal to 1 divided by 27. You're probably thinking, okay, there is no common base, we're going to take the log of both sides. But there is actually a common base. 3 is obviously 3 to the first, but 3 cubed we know is equal to 27. But 3 to the negative 3 is going to be the reciprocal of 27, 1 over 27. So whenever you have a negative exponent, you have to flip it. So notice that we can replace 1 divided by 27 with 3 to the negative 3. There is actually a common base. Okay, there is. 1 over 27 is 3 to the negative 3 because 3 cubed is 27, so that means 3 to the negative 3 is going to be 1 divided by 27. So make sure you understand that part. Now, let's say that, well, this is going to be 3 to the first raised to the x squared plus 4x, so it's just going to be 3 to the x squared plus 4x is equal to, now we can replace 1 divided by 27 with 3 to the negative 3. Now, since the bases are the same, we have 3 here and a positive here. That means the exponents are equal to each other. So we can say that x squared plus 4x equals negative 3. Now, in some way, I want to be able to factor this trinomial, so I'm going to add 3 to both sides. So x squared plus 4x plus 3 is equal to, let's just cancel 0. Now, to solve for x in this one, I recommend factoring this one. So we're going to find two numbers that multiply to 3 that add to 4. And that's going to be, well, 1 and 3. So, yeah. Yeah, it's going to be 1 and 3. 1 and 3. It's going to be x. 1 times 3 is 3, 1 plus 3 is 4, yeah. So that's going to be factoring to x plus 1 times x plus 3, because whenever you have a trinomial, when the a value or the leading coefficient is 1, you have to find two numbers that multiply to the constant term and that add to the middle term. Now, x plus 1 times x plus 3 equal to 0. Now, if you set each factor equal to 0 using the zero product property, if x plus 1 equals 0, that means x has to be equal to negative 1. And if x plus 3 is equal to 0, that means x has to be equal to negative 3. And those are our two solutions for that example. So let's try another example for you to become good at exponential equations. So let's say we have... Now what about this example? Let's say we have 2 to the x squared times 2 to the 3x is equal to 16. So what can you do in this case? Well, first of all, I wouldn't recommend converting these into a common base. In this case, that's not really going to work because we're multiplying here on one side, so that's not really going to work. However, notice that we have a common base already. Whenever you're multiplying exponents with the common base, you can just add the exponents. So this is just going to be, we keep the base the same, and 2 is going to be 2 to the x squared plus 3x, because whenever we multiply by a common base. So 2 to the x squared plus 3x is equal to 16. Now at this point, this is where we want to convert into a common base. So we can rewrite 2 as 2 to the first, or simply this is just going to be 2 to the x squared plus 3x. Is equal. Now for 16, we're going to write that as 2 to the 4th power. So once you have that, since the bases are the same, we have 2 and 2. That means the exponents are equal to each other. X squared plus 3x is equal to 4. I'm going to move the 4 to the other side, and when I do so, it's going to turn to negative 4 is equal to 0. Now two numbers that multiply to negative 4 and that add to 3 are 4 and negative 3. 4 and negative 1, sorry. So that's going to be x plus 4 times x minus 1 is equal to 0. Don't forget that part. Now, if x plus 4 is equal to 0, if we push that down, so x is equal to negative 4. x minus 1 is equal to 0. If we use the zero product property, add 1, x equals 1. So those are the two solutions for this example. Now let's try this one. Let's say we have. Now this example I'm going to show you might seem overwhelming, but if you think about it, it's not going to be that bad. So it's going to be 4 to the 2x minus 20 times 4 to the x plus 64 is equal to 0. Now, it might seem overwhelming, but if you think about it, it's actually not going to be overwhelming. No, nothing is overwhelming. So, in this case, we need to use substitution. We need to use something called the substitution method. Use substitution once you get into calculus and stuff, but substitution here. So, notice that 2x is twice the value of x. See, the first exponent is twice the value of the middle term exponent. Whenever you see the first exponent is twice the value of the middle term exponent because 2x is twice the value of x, whenever you see that case, you need to use substitution. And we're going to use the letter u. We're going to use the letter u. So let's say that we have, so u we're going to make equal to the middle term, 4 to the x. And the reason is, if u is equal to 4 to the x, that means u squared is going to be 4 to the 2x. And the reason why we did that is this very complicated expression will just turn into a simple trinomial which we can factor. So u equals 4 to the x. Well, u squared is equal to 4 to the 2x, so we can replace that with u squared minus 20. Now 4 to the x is u plus 64. And let me just write this a little bit smaller so that you can see. Oh, my forehead. U squared minus 20u plus 64 is equal to 0. Now, notice that this complicated expression turned into a trinomial, which we can factor. So that's why you should use substitution whenever the first exponent is twice the value of the middle term exponent. So, two numbers that multiply to 64 and that add to negative 20 is going to be negative 16 and negative 4. So it's going to be u minus 16 times u minus 4 is equal to 0. Now, if u minus 16 equals 0, u equals 16. And if u minus 4 equals to 0, u equals 4. Now we can again replace that with 4 to the x because that's what it was originally. So we need to transform back, like we were in terms of u, now we need to transform in terms of x. So 4 to the x is equal to, we can rewrite 16 as 4 squared. And u again is going to be 4 to the x, and we can rewrite 4 as just 4 to the first power. Now, the reason why I did that is since now the bases are the same, so now we can easily find the value of x. So the bases are the same, so the exponents are equal to each other. So x is equal to 2. It's really direct in this case. And for this one, same bases, so x is equal to 1. And those are the two solutions for that example. So as you can see, it wasn't actually that bad. All we really need to use is substitution, and then we need to travel back to the x world. We were in terms of u. Need to go back in terms of x now. And yeah, that is it for this video. So if this video helped you out, make sure you subscribe, turn notifications on, because I'm going to be posting a lot of educational videos and complex videos that you're going to need help with. So make sure you subscribe, turn that notification on, that way, notification bell on, that way you don't miss any like important topic that I'm going to post. So make sure you do that, and I'll see you in the next video. Bye.